Think about an inverse as something that undoes something else. For example, let's say you start with a vector in two-dimensional space. If a transformation t moves that vector from where it starts at A to another spot, which we'll call B, then the vector at A under the transformation t moves to B. If that's how we define the transformation t, then the associated inverse transformation of t, which we call t inverse, will start with the vector at B and then move it back to A, which is the spot where it started. Or for the inverse of a matrix, given some matrix A, we can say that multiplying A by its own inverse will always result in the identity matrix. It's also important for us to understand by the end of this section that not everything is invertible, meaning not everything has a defined inverse. Some transformations aren't invertible, and some matrices are not invertible. They don't have an inverse. So in the lessons in this section, we'll define inverses, investigate when something has an inverse and when it doesn't, and then we'll close out the section by talking about how to solve systems using inverse matrices.